Quick revision video on calculating an enthalpy change for a reaction using enthalpy changes of formation using the vector approach. So if you imagine a generic reaction A going to B and we want to find the enthalpy change for that reaction, if we use an enthalpy changes of formation, we draw what's called a formation cycle. So we'll have formation data for all of the reactants and all of the products, and basically the cycle creates all of those from the elements. So the arrow going up to A represents the enthalpy changes of formation of the reactants in that AB equation. So if there's more than one, that would be the sum of the enthalpy changes of formation of the reactants, and likewise the arrow going up to B is the sum of the enthalpy changes of formation of all the products. Then if we apply Hess's law, which says if a reaction can take place by two routes, the enthalpy change for each route is the same, providing you start and finish at the same places. There's two ways to go from A to B. There's the green route or there's the red route. So the vector approach looks at the direction of the arrows. So you can see that in the red route, this arrow up to A is going in the wrong direction. We want it to go that way. That arrow's fine because it's following the red arrow, if you like. So mathematically what we would do is we would say the enthalpy change for this route is equal to this one, the sum of these, minus this one, because this one's going in the wrong direction. So when you use enthalpy changes of formation, the enthalpy change reaction is the sum of the products' enthalpies of formation minus the sum of the reactants' enthalpies of formation. So we'll put that into practice with this question here. But I use the data in the table to calculate a value for the enthalpy change for the reaction. So straight away we're looking at the data supplied. I know it's not very clear, but these are enthalpy changes of formation. So we need to draw a formation cycle. So we have elements at the bottom and the arrows point up from the elements to the chemicals in the equation. So we see these are, or this is the reactant and these are the products. So then if we put the values in, so starting with the reactants, we've got 2 moles of sodium hydrogen carbonate being formed, so that will be 2 times minus 948. And then on the product side, we've got 3 products to form, so that's going to be minus 1131 plus minus 394 plus minus 286. Then we'll apply Hess's law. We've got the green route with the unknown in and the red route, and then just apply what we've just said. This arrow is going in the wrong direction, so we're going to subtract this from the sum of these. So the enthalpy change, the unknown one, products minus reactants, and we get an answer of plus 85 kilojoules per mole.